Good evening, students. Welcome to our next session on topic 3D geometry. So far we have covered our most of the topics which are related to 3D geometry. So we are only left with few topics. So we'll try to do that in our this session of 3D geometry. So far we are dealing with our line, equation of line, angle between line and all. Right. So today we'll just have like a finishing for our line and then we'll jump into our plane. So after our line, we are going to talk about plane, like equation of plane in different forms and how to find angle between any two planes. And once we're done with our plane, then we'll be getting into our plane come line. That is how to find angle between a plane and line. So those and all topics will be coming into picture. Right. So I hope most of you are here. So we'll just have a quick overview of what and all topics we have covered so far and what and all the topics we are going to focus in our today's session of 3D geometry. So coming to our today's session. So in this today's like in our previous session we have already covered this concept of angle between two line segments, right? So we have seen the formula in different formats. So what if we are given with the direction ratios, how to find that? Let's go. If we have given with direction cosines, how to find the angle between the lines? So those and all we have seen with respect to trigonometric functions. That is, we have seen in our cos theta, in terms of cos theta, as well as in terms of sin theta for both direction ratios as well as the direction cosines, right? And we have seen the next concept here also, that is how to find the shortest distance between skew lines. So for this finding the shortest distance between skew lines, we have seen our formula in two different forms. So one is in terms of our vector representation and the other is in terms of, as usual, our Cartesian form. So Cartesian form is nothing but using our coordinates of the point, right? So as we have seen the formula for our shortest distance between skew lines, in the same manner we are going to have one more formula, that is shortest distance between parallel lines. So we'll just quickly go through the formula, like how to find the distance between parallel lines, because we obviously know that the shortest distance between any two parallel lines is nothing but the perpendicular distance, right? So the thing is here how to find, like if we are given the lines in terms of vector forms, so how can we directly, like instead of converting our vector form of equation to Cartesian form of equation, we can actually directly use that vector equations and we can use the formula which I'll be discussing in our today's session. So once we are done with distance between parallels, with that we had the end of our lines. So after the lines, the next concept which we are going to discuss is plane and the equation of plane. As I mentioned, so what is basically a plane? So a plane is nothing but a typical flat surface. In the previous session also I have given an example for plane, that is nothing but a sheet of paper. It's as simple as that, right? So coming to the equation of plane. So how we have seen different forms of equations for our lines. In the same manner, we are going to see different forms of equations of plane. In some cases, we'll be seeing in two representations, vector representation as well as our Cartesian form, because in some questions, if they have given in terms of vector forms, so there is no need for us to convert into Cartesian and then we further solve it. So for that particular reason, we should be aware of the two representations. That is one is our vector representation and the other one is our Cartesian form of representation. So after the plane and the equation of plane, we are going to discuss the coplanarity of two lines. So we know what are coplanar lines and all. So either it can be intersecting or parallel lines. So that and all we know. But to get that coplanar lines, what can be the condition? So the condition we are going to see here, right? So here we are going to see the condition of our coplanarity. in terms of our Cartesian form of lines. Right. So once we are done with our coplanarity, of two lines, the next one is finding the angle between line and a plane. So far what we have seen, how to find the angle between two line segments. And here, after the plane and equation of the plane, even we are going to see how to find the angle between any two planes. Right. And the final concept is how to find the angle between a line and a plane. Right. So these are our typical concepts we are going to cover in today's session. So if we could finish these topics, and with that we actually finished our chapter of 3D geometry. If we are able to finish it, that's good enough. If not, we'll just continue our next session. And in our today's session, we'll just at the end of the session, we'll do some JEE level of questions, because so far we are doing a very basic levels. One or two questions we just done in our mains level, but not many. So in today's session, we'll just do questions which are related to the model type of questions which are related to our JEE level. So let's get started. So here, let's see two lines which are parallel. So here my line 1 and line 2. So these two lines are parallel to each other. So here if it's a line, I know how to write the equation of this line. Right. So here in this line, I have taken a point that is S, and the position vector of this point is nothing but A bar, that is A1 bar. Right. And another in another line, that is L2, I have taken the point T, and the position vector is nothing but A2. Right. If I drop a perpendicular, so the TP is nothing but my shortest distance between any two parallel lines. So what will be my equation line 1? So equation of line 1, let it be R1, that is equal to A1 plus lambda into B bar. So what is B bar here? So B bar is a vector of a line which is parallel to the both the lines L1 and L2, because L1 and L2 are parallel to each other. If we take a line parallel to either L or L1 or L2, it's obvious that that particular vector will be parallel to both the lines L1 as well as L2. So here comes our next equation of line 2 is A2 bar plus mu into B bar. So these two will be my equations of two lines here. Then here comes my formula. So if you remember, for our skew lines, what is our formula there? There it is B1 cross B2 bar into A2 bar minus A1 bar by modulus of B1 bar cross B2 bar. So this is the formula we have seen for finding the shortest distance between two skew lines. But if you remember, skew lines are the lines which are neither parallel nor intersecting. Right. Whereas our parallel lines means they'll be parallel to each other, which means there is no need to take two vectors which are parallel. Right. So instead of B1 and B2, here only one B vector is enough, because both the lines L1 and L2 are parallel to each other. So if we take the vector B, that will be obviously parallel to both the lines. But that's not the same in our skew lines, because skew lines are neither parallel nor intersecting. Right. So if I take some B here, this will be parallel to my L2, for example. So this is my B2 bar. So if I take my B2 bar, this will be obviously parallel to my L2 but not L1. So for L1, I have to take one more vector which is parallel to B1, that is B1, which is parallel to my line L1, that is B1 bar. So that's why in our skew lines, we'll be having B1 and B2, two directional vectors, whereas in our parallel lines case, we'll be having only one vector, that is B. So here comes our formula for finding the shortest distance between any two parallel lines, which is given to be. So this TP is my shortest distance D. So that will be equal to B bar cross A2 bar minus A1 bar by modulus of B bar. So this will be my formula to find the shortest distance between any two parallel lines. Right. So let's see a question. So just using the formula, make it fast and try to solve this question. So as I have mentioned already the formula, so it's simple that you just apply the formula, but you have to understand that what is your B and what is your A bar, A1 bar and what is your A2 bar and all. If once you're clear with those sections, it's easy to find the distance between any two parallel lines here. So quickly try and find the distance between parallel lines here. So I have given two lines. So I have given the equations of those two lines in my vector form. So this is my first line equation, r bar equal to I cap plus 2j cap minus 4k cap plus lambda into 2I cap plus 3j cap plus 6k cap. So this is my equation of line 1 and let this be my equation of line 2. So here comes, you have to find the shortest distance between these two lines. So here I haven't mentioned whether the lines are parallel or skew lines or intersecting lines, something else. But by looking at the equations of the line, you can directly identify what are those lines. Right. So by looking at the equations of lines, you can identify whether the given lines are parallel lines or whether the given lines are skew lines. Right. So that you have to understand first. Then only you could able to conclude which formula you have to apply to find the shortest distance between the given two line segments. So by looking at the equations, you might have understood what type of lines are given here. Can you tell me? So how can you say that, from what perspective, from what link which is given in the line, you can predict that the given lines are parallel or not? Come on guys. So can you tell me the reason? Anyone? So first thing is you have to identify what type of lines are given here. Because in the questions they haven't mentioned what type of lines are given. They just directly asked you to find the shortest distance between the given two line segments which have the equations are given in terms of vector form. Here Shivaranjani has given me that answer to be 1 by 7. Can you check Shivaranjani once again? So here the formula which you have to use is B bar cross A2 bar minus A1 bar by modulus of B, and here it will be complete modulus, which means here if you observe B bar cross A2 bar minus A1 bar will also be a vector. Right, here we are doing a cross product, so the result will also be a vector only. So here that's why we will be having the entire modulus, which means we have to find the modulus magnitude of this vector here. Maybe there you might have missed the link, Shivaranjani. So just give it a try and let me know what's the answer. The denominator is correct, yes, but the numerator you have to check once. Anyone else? Anyone else got the answer? Shivaranjani, just check your answer once. And what about others? So apart from Shivaranjani, no one replied here. So basically, if you observe this line equations R1 and R2 here, so this is our A1 bar and this will be my B bar. And here both the vectors here are same, which means this is B bar and this is also can be considered as B bar, which means the given two lines are parallel to each other. So from here I can say my position vector, my vector A1 is nothing but I cap plus 2j cap minus 4 cap. And what about my A2 bar? So my A2 bar will be this vector, that is 3i cap plus 3j cap minus 5k cap. Then from here, what is my B bar? My B bar is directly this common vector, that is 2i cap plus 3j cap plus 6k cap. So once we got all the vectors from the equations of line A1 bar, A2 bar and B bar. So now let's try to find our B bar cross A2 bar minus A1 bar. So first let's just find our A2 bar minus A1 bar first. So let's just find that. So A2 bar minus A1 bar. So this will be equal to A2 minus A1. So 3 minus 1 will be 2. So 2 I cap. So 3 minus 2 will be 1. So plus 1 J cap. So minus 5 minus 4. So plus 4. So it will be minus K cap. So this is my vector A2 bar minus A1 bar, that is 2i cap plus j cap minus k cap. So now what and all required information, I got everything. So now let's substitute and find the answer. So my thing here is I have to find my cross product of B bar as well as A2 bar minus A1 bar. So let me take I cap, j cap and k cap here. So B bar, so what are the coefficients of B bar? 2, 3 and 6 here. And coefficients of A2 bar minus A1 bar, that is 2, 1 and minus 1. So you know how to find this typical cross product. So even in our previous class also we have done how to do the cross product, and even in your physics you might have learned that. So let's just do that. So I cap into, so minus 3 minus 6, so it will be minus 9 and minus j cap. So this thing will be eliminated. So minus 2 minus 6 2s are 12. So it will be minus 14 plus k cap into 2 minus 3 2s are 6. So 2 minus 6 will be minus 4. So now if I see here, it will be minus 9 I cap. So here minus into minus plus 14 j cap minus 4 k cap. So what is my numerator here? So my numerator consists of a vector, that is minus 9 I cap plus 14 j cap minus 4 k cap. So this modulus I have to find, and in the denominator is modulus of my b. So what is modulus of b? That is 2 square plus 3 square plus 6 square. Right, so let me, as of now, you might have understood what we are trying to find here. Right, so let's just erase this part. I hope so you're following. So yeah, so let me erase this part. Okay. So far we got our B bar cross A2 bar minus A1 bar vector. We already got that. So what is that vector? B bar cross A2 bar minus A1 bar is nothing but minus 9 I cap plus 14 j cap minus 4k cap. Right, as well as what is our b vector? So my b vector is 2i cap plus 3j cap plus 6k cap. So now how I will be using my formula? So my d will be equal to modulus of b bar cross a2 bar minus a1 bar by modulus of b. The same thing as whole we can take modulus. Right, so modulus of this one is minus 9 whole square plus 14 whole square plus minus 4 whole square under root, and in the denominator 2 square plus 3 square plus 6 square under root. So what will be my denominator? So here it will be 9 square and 4 square and 14 square, 160, 196, 81 plus 196 plus 16 by 4 plus 9 plus 36 under whole root. So if we sum it up, so we end up having in the numerator 293 under by denominator 49. So our 49 we can take it as square root, where my distance d will be equal to root over 293 by 7. So in final, the shortest distance between the given two parallel lines is nothing but root over 293 by 7. Yeah, okay, Shivaranjani got it. Even Siddharth has given the answer. Okay, fine. So this is the, we'll be using the formula and finding the shortest distance between any line segments. So with this, we are done with our line part. So let's just get into our plane part here. So basically, we know plane is nothing but a simple flat surface, as I mentioned. So it will be like a sheet of paper. If you take it, that is nothing but example of our plane, which is a simple flat surface. Right. So here there are some points you have to keep in mind. That is, a plane is determined uniquely if any of the following is known. So we can actually determine a plane if any of these given points are mentioned in the question. Right. So the first one is the normal to the plane and its distance from the origin is given. Right, that is equation of plane in normal form. So here you will be seeing, as I mentioned, we'll be trying to find our equation of line in different forms. So one of the form is in normal form, that is, if this is my sheet of paper and I'll be having a perpendicular line, something like this. So if my hand is a sheet of paper like this, and if I'm having a line, so this will be a perpendicular line, so which is the normal line to my plane here. Right, so if we know that the distance from this normal line to the origin, from there we can directly get the equation of plane. So in our future slides, I'll be explaining you that how we'll be getting the equation of plane in normal form with respective figures, right? And the second point is it passes through three given non-collinear points. So any plane will actually pass through three given non-collinear points. So what is our collinear points definition? So collinear points are nothing but when 3 points lie on the same line. So non-collinear is quite opposite to what? Right, which means a line, actually a plane, will be passing through 3 given non-collinear points. So it's a basic typical points which we are going to see, which is related to plane. But no need, if you get it, that's fine. If not, we are again going to see the first point is nothing but our equation of plane in normal form, and the second point is nothing but again non-collinear points equation form. That also we are going to see in our future slides of our today's session 3D geometry. Right. So first let's see here. I have given you a figure. Right. So here this is my x-axis. The red line is my x-axis. The green line is my y-axis, and this blue line is my z-axis. Right. And here I am taking a plane. So what is my plane here? So this is a plane. If you observe, this is a flat surface here. So this is my plane. Right. And from this origin to my plane, I have dropped a perpendicular. So this is my perpendicular, that I can even say normal. Right. So here, if you observe, this length is d. Directly from the figure, you can say that my distance d is not equal to 0. Isn't it? And then if you see this line, so let me take the position vector on bar. because this is my point N and I am taking with respect to origin here. So I can write it to be a position vector ON bar. So this is nothing but my normal, that is my perpendicular line to the plane. So normal from origin. Right. So first we have what we have taken. We have taken our three axes X, Y and Z, and here I have taken a plane. So to that plane I have dropped a perpendicular from my origin, which is ON. That is a position vector ON bar. So this ON bar, as it's a perpendicular, that is nothing but we can say it to be a normal from the origin. Right. So now let's consider a unit vector. So along this line, along this ON bar, I am considering a unit vector N bar. So what is our unit vector? So unit vector is nothing but N bar by mod N. Right. So if I am having the vector N, so I can write my unit vector to be N bar by mod N. So unit in the sense the always the value will be unit. So here this I am considering a unit vector along this position line ON bar. Right. So if I am having along this line ON bar, if I have a position vector, according to vector rules, we can write our ON bar position vector to be the distance of that line into the unit vector. So you will be seeing this again in our vector form in detail, but as of now you just remember that whenever we are having a line segment with a distance d, so that vector of that line ON bar can be written as the distance of that line into a unit vector. So here I am taking my unit vector to be N bar. Right. So now what I'll take one more point on my flat surface, that is my plane surface. So in this second figure you can observe I have taken a point P on my plane surface. Right. So if I have some point on my plane here, I could able to join my 2 points N and P because both are present on my plane surface. Right. So if I join like this, what it will happen? So ON is a perpendicular and PN here is the perpendicular to my vector ON. So here I am having two lines, that is PN and ON, which are perpendicular to each other. Right. So when two vectors are perpendicular to each other, according to vector rules, the dot product of that will be equal to 0. That means this is my vector NP bar and here my vector ON bar. So the dot product of this NP bar and ON bar will be 0 according to vector rules. So here we have learned two rules which are related to vector point of view. The first one is if we are having a vector form, vector ON, right? So that can be written as the distance, the length of that vector into unit vector. So that is the first point we have discussed here. We have learned. And the second one is when two lines are perpendicular, the vectors of those two lines dot product will be equal to 0. That means here my PN line is perpendicular to my line ON, isn't it? So from the figure we can identify that. So as these two lines are perpendicular to each other, my position vectors, that is NP bar into ON bar, the position vectors of these two lines dot product will be equal to 0, which means NP bar dot ON bar will be equal to 0. Right. So now the next step here is I am just tilting the figure. So if you observe this figure here, what I have done, so this is my point, that is normal point on my plane surface, and this is my point P I have taken on my plane surface, and now I am going to join this P to my origin. Right. So P is my arbitrary point here. What is my P? P is some arbitrary point on my plane surface. So the position vector of my P with respect to origin will obviously my R bar. Right. So if we separate this triangle here, that is OPN, and maximize it and look at, so it will be looking something like this. So this is my point P, arbitrary point on my plane, and this is my point N, that is normal point on my plane, and this is my O, origin. right? And the vector of this OP line will be R bar, and my vector of this ON line I have already got D into N cap, right? So here, if I take my vector NP bar, so I am trying to take this vector because I know these two vectors I have already got it. So this vector is R bar and this vector is D into N cap. So now I have to find my vector NP bar. So NP bar can be written as OP bar minus ON bar in terms of position vectors. This concept we have already discussed. So what is our OP bar? OP bar is nothing but R bar. And what is our ON bar? That is D into N cap. So from here, my NP bar is nothing but equal to R bar minus DN bar. Right. So in our previous slide, we have ended up having this result, that is our NP bar dot ON bar is equal to 0 because the lines NP and ON are perpendicular to each other. So the dot product of those two vectors will be 0. Right. So now what is my NP vector? So I got my NP vector to be R bar minus D into N cap, and my ON bar is nothing but D into N cap. So if we try and simplify this, so R minus D N cap, so D N cap. So if we try and simplify it, we end up having the equation to be R bar dot N cap is equal to D. So let me do that also. So let's multiply it. So it will be R bar dot D N cap minus D square N cap into N cap is equal to 0. Right. So from the both I can take D common. So if I take D common, here what it will be remain? R bar dot N cap minus N cap into N cap will be 1 only. So we can leave it. So it will be minus D is equal to 0. So here D will be 0 and we will be remaining with R bar dot N cap is minus D is equal to 0. So by equating it to 0, we end up having R bar dot N cap is equal to D. Right. So my final equation of a plane in terms of a vector form is nothing but, so we can keep it in this way, the equation of a plane passing through a point P and having a normal distance from the origin is D, then that equation of that plane is given by R bar dot N cap is equal to D. So what is D here? Distance from the origin to the normal point on the plane. Right. So this is my equation of plane in vector form. Right. So equation of plane passing through a point and having a normal to the plane in vector form is nothing but given by R bar dot N cap is equal to D. So our final equation here in vector form is nothing but given by R bar dot N cap is equal to D. So this will be my final equation here. So I hope you got it. So here the points which we have to remember is when we have two perpendicular lines, the position vectors dot product will be 0. So that is one point. And the other is if we are having a vector with a distance D, then that position vector can be written as the distance into the distance multiplied with unit vector. Right. So this is my equation. So if you are getting confused, no issue, you'll be understanding in our future when we are dealing with vectors in proper. But you should be seeing this equation. You should keep this equation in your mind, that is R bar dot N cap is equal to 0 is my equation of plane when a normal N is having it and the plane is passing through point P. So let's see the normal form of equation for the same thing in terms of our Cartesian form. Right. So what is our vector form which we have seen? R bar dot N cap is equal to D. Right. So what is my R bar? So R bar is nothing but my position vector of a random point P. Right. That is my arbitrary point P. So what will be my coordinates of arbitrary point x comma y comma z? So then from here what will be my R bar vector in terms of using coordinates? So it will be xi cap plus yj cap plus zk cap. So this will be my R bar. And N cap is nothing but normal. Right. Because N cap is nothing but with the distance D. So it is a normal vector. Right. So N cap is my unit vector to the normal. So as I mentioned in our previous session, our n cap is nothing but n bar by mod n, right? So n cap is also vector where having the coefficients to be direction cosine. So I have explained in our previous session only. If you are having doubts in that, please go through our previous session. So there I have explained this clearly, how to have this n cap. So my n cap vector will be in terms of L I cap plus M J cap plus N K cap, because my n cap is a vector having the coefficients to be direction cosines, right? So that's why I'm taking L, M and N. So D is a distance. So let's substitute here. So in place of R bar, I can substitute Xi plus Yj plus Zk. So dot product of this into Li plus Mj cap plus Nk cap is equal to the distance D. So it's simply dot product. So it will be Lx plus M into Y plus N into Z is equal to D, which means my normal form of equation of plane in terms of my Cartesian coordinates, that is given to be Lx plus My plus Nz is equal to D, where L, M and N are my direction cosines of the normal to the plane. So that those are the direction cosines of the normal to the plane, and my D is the distance from the distance to the plane from the origin. Right, in this figure you might have observed. So this is my distance from the origin to the plane, right? So that is my distance D, and my n cap is this unit vector, right? So this is my equation of a plane in normal form. For both, in both representations we have seen, that is in vector form we have seen, as well as in our Cartesian form. So let's do a question here. So I have explained that form into representations very clearly. I hope you got an idea. So I'm leaving this question to you. Just give it a try. We'll just take few minutes. So find the direction cosines. So that's why I'm pointing out very clearly when I'm talking about a unit vector, that is nothing but equal to n bar by mod n, which relates to your direction cosines. So let's solve this question here. Find the direction cosines of the unit vector perpendicular to the plane r bar dot 6i minus 3j minus 2k plus 1 equal to 0. So here the equation of plane is given, and you have to find the direction cosines. Give it a try. How can you find this? Just a simple logic here. Very simple logic. So this question is, we can say, a mains level question, because many of students mistake here. They'll do mistake when it comes to direction cosines and all. So it's a mains level of kind of questions. So that's why I'm just informing, like I'm just telling you to give it a try first, and then we can discuss. So when you try and read the question and try and solve the question, then only we'll be understanding where we are actually facing the difficulty while solving the question, so that we can cover up that like when in our next questions and all. I asked about direction cosines. So you have to give three values, L value, M value as well as N value. Or else there is one more way, you can directly convert this into your Cartesian form, then it will be easy. So our R bar is nothing but xi cap plus yj cap plus zk cap. So in place of R bar you can substitute xi plus yj plus zk cap. This dot product into 6i cap minus 3j cap minus 2k cap. So is equal to minus 1 here. So here distance cannot be minus 1, so simply multiply with minus 1, multiply with 1. So k z k cap. So if we multiply, so it will be minus 6i cap plus 3j cap plus 2k cap is equal to 1. Correct. So minus 6 by 7, 3 by 7 and 2 by 7. Okay. So this is a vector here. So when we divide with the modulus, so these are our direction ratios, right? So minus 3, 3 and 2 will be direction ratios for any line. So that we have already seen. So if we are having direction ratios, from where directly we can find our direction cosines. So Siddharth has given the answer minus 6 by 7, 3 by 7 and 2 by 7. Okay. So here, without taking all this, what we can do is they are talking about only normal ones. So this is my normal vector. Right. So whenever we are having any vector, the coefficients of those I, j, k are nothing but our direction ratios or not. So here my A is 6, my B is minus 3 and my C is minus 2. Sorry, here after multiplication I have to eliminate, right? Sorry. So it will be plus 3, plus 2 and minus 6. So I got my direction ratios. So if you got your direction ratios, we know how to find direction cosine. So it will be A by root over A square plus B square plus C square and B by root over A square plus B square plus C square and C by root over A square plus B square plus C square, which you end up having your direction cosines to be equal to minus 6 by 7, 3 by 7 and 2 by 7. So I think you got it. So moving on to our next one. So our next form of equation is a general form of equation. That is, initially we have seen our normal form, that is with related to our direction cosines and all. But here we are going to see with respect to our direction ratios. So the equation of a plane is given by ax plus by plus cz plus d equal to 0, where my ABC are the direction cosines. Sorry, direction ratios. So if I am having direction ratios also, the equation of the plane will be ax plus by plus cz plus d here. So here it is plus d. So plus d equal to 0. So this will be my equation of the plane. It is a general form, that is with respect to my direction ratios of normal to the plane. So in general, whenever, why we are call this equation of plane to be a general form, because in most questions in exams, so mostly they'll be giving the equation of plane is the most general way. So when we have x, y, z in terms of a, with questions a, b, c and all, so that is the most general way of writing any equation. So here the general form of equation of a plane is nothing but ax plus by plus cz plus d equal to 0, where my ABC values are nothing but my direction ratios. Right, so direction ratios of the normal to the plane. Right. So the next form of equation is equation of a plane perpendicular to a given vector and passing through a given point. Right. So when we are having a vector which is perpendicular to it, right, and it is passing through a point. So then the equation in our vector form is given to be r bar minus a bar dot n bar, the vector of the normal, that is the perpendicular vector here. So this is my perpendicular vector and this is my point, the position vector of the point which the plane is going through. Right, so here my equation of a plane which is perpendicular to a given vector and passing through a given point is nothing but given by r bar minus a bar dot n bar equal to 0. So in general, you should aware of all these steps, but mostly we'll be using our general form of equation of plane only, mostly, right? So in terms of Cartesian form, so if an equation of the plane is actually passing, so a plane is passing through a point with coordinates x1, y1 and z1 and normal to a plane, right here, ratios of normal to a plane. So a normal will be there and the direction cosines of the normal is given to be ABC. Then what will be the equation of that plane? So the equation of that plane is given to be A into x minus x1 plus direction cosine B into y minus y1 plus direction cosine C into z minus z1. So this will be my equation of the plane passing through the point, passing through the given point x1 comma y1 comma z1 and perpendicular to the normal having the direction ratios A, B and C. So let's do a question here which is related to that part. So we have identified and seen both the Cartesian and vector forms of it. So in vector form, the equation is r bar minus a bar dot n bar is equal to 0. Right. So that's what we have seen. So just try and write the equation here. So first here they have mentioned both vector and Cartesian. I suggest you to write in terms of Cartesian form first. For this, so first write Cartesian form. So write the equation in Cartesian form of it. So it will be very easy. Just a simple application here. So this is not a typical mains question. It's a very elementary level question. But what we have done in the previous one, that is a mains level kind of question. So make it fast. So you can find the equation in Cartesian form directly. So vector form is nothing but simple substitution. That's it. Apart from that, we can't do anything. So you just try and find the Cartesian form of equation directly. Has anyone got the answer? Did anyone solve it? So it's simple, guys. I have given the point. I have given the direction ratios. Simple thing. So I think we'll be requiring one more last lecture for our 3D geometry. So today we'll just try and at least complete the Cartesian plane and equations of plane and all, so that in our next sessions we can go ahead with the relation and finding the angle between line and plane and all. And if possible, we can do some advanced level questions also in our next session. So did anyone got the answer for this? Why it's taking too much time? Simple question, right? So I'm just asking you to write the Cartesian form. No need to write the vector form of here. Okay, Siddharth has given the answer. 2x plus 3y minus z is equal to 20. Exactly, correct, Siddharth. So Siddharth has given 2x plus 3y minus z equal to 20. So what about others? Did you guys get the question so that you would be able to solve it? Okay, Siddharth even given in terms of vector form, no issue. So vector form is nothing but r bar minus a bar into n bar equal to 0. So my r bar minus a bar is the position vector of the point. So it will be 5i plus 2j minus 4k. So r bar minus a bar. So into n bar is the vector of perpendicular one. So that will be 2i plus 3j minus k bar. So this will be equal to 0. So this is my vector form of equation. Okay, Shivaranjani also done it. So we'll just move ahead, guys. So the next one is when we are having 3 points, that is 3 position vectors, we can say in terms of Cartesian form, we can say when we have a plane passing through 3 non-collinear points. So that's what I mentioned in our first slide when we are discussing about the plane. In that first point is regarding our equation of plane in normal form, and second point is talking about non-collinear points, right? So that is nothing but equation of a plane passing through 3 non-collinear points. So let the non-collinear points be RST. So if we are having 3 non-collinear points on the plane, so they will be having position vectors, right? So my OR bar is nothing but position vector of that point. So I am taking it to be OA bar. My OS bar is nothing but B bar. And my OT bar is a position vector with respect to my point T. Let that be C bar. So if I am having 3 non-collinear points and my plane is passing through that 3 non-collinear points, then my equation of the plane in vector form is given to be r bar minus a bar cross, so r bar minus a bar cross b bar minus a bar, here again cross c bar minus a bar. So complete cross products here. So this will be equal to 0. So this is my equation of the plane passing through 3 non-collinear points, right, who's having position vectors a bar, b bar and c bar. So this is my equation of plane in vector form. So now let's see what will be my equation of plane passing through 3 non-collinear points in my Cartesian form. So in Cartesian form, that is nothing but if I'm having 3 non-collinear points, generally the equation will be following this determinant. So that is x, y, z and 1. So x1, y1, z1. So this is my coordinates of point R, for example. And x2, y2, z2. These are my coordinates of point S. And x3, y3 and z3. So these are my coordinates of point T. Right. So these three are having coordinates x1, y1 and z2. My S point having coordinates x2, y2 and z2. And my point T is having coordinates x3, y3 and z3. So we can't actually directly find the determinant with this number of columns and rows, right? So that's why we could convert that into in this typical format. So that is nothing but x minus x3, x1 minus x3, x2 minus x3. That is my first column. And in second column it will be y minus y3, y1 minus y3, y2 minus y3 will be my second column. Similarly, my third column will be having the z terms, that is z minus z3, z1 minus z3 and z2 minus z3. So in some questions we can expect question related to this non-collinear points, mainly in terms of our Cartesian format. So this will be my direct. Okay, so now try and solve this question. So we'll just wind up our session with this question. So as the question given, find the equation of the plane passing through these 3 points, so which are non-collinear obviously. I have given here. So 2, 5, minus 3 is my point R. Point S is having coordinates minus 2, minus 3 and 5. And point T is having coordinates 5, 3 and minus 3. So you can find in vector form. So try and find in vector form. Because for Cartesian form, it's simply substitution there. Okay, first we'll do one thing. First we'll try and find in vector form and then we can see. So what is the vector format here? What is the formula? So R bar minus A bar. So here I have explained. So R bar minus A bar into, so here it will be a cross product. So B bar minus A bar. Again here it's a cross product, C bar minus A bar. So this will be in terms of my vector form of equation. So this should be equal to 0. You can directly substitute. I'm not asking you to just simplify and all. You can just find this cross product vector directly and you can substitute it. I'm not asking you to simplify it further, but you can just substitute and let me know. Because I know that you guys know how to do this simplification and all. So we won't waste much time there. Did anyone got the answer? Shyam, Siddharth, Sivaranjani, anyone? Why others are not giving any reply for answer? Shraddha, Tara, and all, Rachel. So R minus 2i, okay. 5j minus 3k, okay. That is your A bar. So you have to find the cross product here. Okay, fine. So here your A bar vector is nothing but 2i cap. So this is my first one, right? So it will be 2i plus 5j minus 3k. So this is my R bar minus A bar. And this bar you have to do the cross product. For that, first you should find what is B bar minus A bar vector. And the next you have to find what is the C bar minus A bar vector. Minus 4i, 8j, 8k. Okay, cross 3i minus 2j. Okay. I didn't mention to solve you, simplify it further. You can leave it as it is. So yeah, correct. So Siddharth has given the answer. What about others? So here what is our B bar? So this is B and this is A. So B minus A. So minus 2 it will be directly minus 4 I cap. And minus 3 minus 5 will be minus 8 J cap. Okay. Then here 5 minus of minus 3, so it will be plus 8 K cap. So this is my vector B bar minus A bar. Let's see C bar minus A bar. So C bar minus A bar, 5 minus 2, it will be 3I, and 3 minus 5, it will be minus 2, so minus 2 J cap, and minus 3, minus of minus 3 plus, so it will be 0, so there is no K cap. So here my B bar minus A bar is nothing but minus 4 I cap minus 8 J cap plus 8 K cap, cross product of C bar minus I bar is 3I minus 2J. So if we want to try and find in terms of our Cartesian form, you can substitute the values. So if has any doubts, please let me know. So if anyone has any doubts, please let me know, so that we can just have a discussion in this, and we have a quick discussion on what and all your doubts having. So yeah, so that's all for our today's session of 3D geometry. So we are left with few types of equations of our plane topics related to both line and plane. So that we'll be discussing in our next session, and we'll do some questions even related to our plane and line in our next session of 3D geometry. So that's all for today, guys. So thank you. We'll just continue, and we in our by one more session we can just finish this chapter